Assalamu alaikum wa rahmatullahi wa barakatuh. Today we'll be looking at a very interesting lesson, which is inclined planes. I have in front of you a question that says a loaded bakkie with a total mass of 1750 kilograms travels up an uphill road. The bakkie maintains a constant speed of 72 kilometers per hour during the 570-meter climb. When it reaches the highest point in the road, the bakkie has risen 55 meters above the start of the slope. 6.1. If the work done to overcome friction is 5,84 times 10 to the 6 joules, calculate the average power developed by the bakkie's engine during the climb. So if we look at the 6.1, what we need to know is we want to calculate the average power. And what you know, power is equals to work divided by time. Now, if we look at this question, what is the work done in this question? We see our work done, our net work done, is the work that the bakkie does in going from the bottom of the slope to the top of the slope. And we see that the work that it does in this case is an increase in height. If you look at the kinetic energy, it's constant speed. And they tell you that the work done to overcome friction is that amount. So your net work will be basically your change in your kinetic energy, and you have change in your potential energy, and you have your change in the energy due to friction. So if you look in this case here, we see that our net work done will be, because the kinetic energy is constant, there will be no change in kinetic energy. It will be the work done in your increase in potential energy, which is mgh, plus your work done by friction, work of friction, which is given by the amount that we have here, 5,84 times 10 to the 6. So just to get a little space, I'll just pull this across. We can do the sum nicely. Now, if we continue, the mass of the bakkie is 1750. Gravity is 9,8, and our height is 55 meters, plus the energy gained by friction will be 5,84 times 10 to the power 6 joules. And let's take our calculator and work this out. If you look at it, right, let's just see, it's 1750 multiplied by 9.8 multiplied by 55. It's going to give us 943,250, and that must be added to 5.84 times 10 to the power times 10 to the power 6. That's going to give us just one. Okay, just working on a calculator work that I had a bit of difficulty. This is 5,84 times 10 to the power 6, and you're multiplying that by 1750 times 9.8 times 55. And that's going to give us that amount, and I'll just put it in scientific notation for you. This calculator is giving me difficulty, so I have a calculator in front of me, and I worked out the amount, and I'm going to use the calculator in front of me, and the amount we have is 6,78 times 10 to the power 6 joules. So this is the amount of energy required, or the network done by the bucking going up the slope. Now we've got our work done. Now our time, to work out our time is equals to distance over speed, delta x over delta v. And if you look at our distance that you went up is 570 meters, and your speed is 72 kilometers per hour, which you must change to meters. So 72 kilometers per hour, you divide by 3.6, and you'll get an amount there. Let me just work it out for you. 72 divided by 3.6, and it's going to give us 20. All right, meters per second. So 750 divided by 20. So sorry, 570 divided by 20 will give us 28.5 seconds. 28.5 seconds. Now we can substitute that in our original equation, where we had power is equals to work divided by time. So I'm going right here on the top again. I'll write it in another color because that's what we wanted to work out. Our work done was 6.78 times 10 to the power 6, and our time was 28.5 seconds. And if we work that out, we'll see that we get 6.78 times 10 to the power 6 divided by 28.5 seconds will give us a power of 2.38 times 10 to the power 5. Power is measured in watts. So that is the way we will do our first sum.